Hello, welcome back. The title of this lesson is called the Y-Intercept as the initial value of a function, part 1. I'm actually excited to teach this because this concept has long-reaching and long importance beyond this lesson. I can't actually stress it enough to you. I can't get into the details, but the concepts we learn here are going to stretch years into the future in much more advanced math classes. And also, it seems like a complicated topic that is really not complicated at all. We're going to talk about the idea of an initial value for a problem. And again, when you get into more advanced classes like calculus and other things, we have entire classes on initial value problems, right? So what does an initial value mean? It just means how much of whatever it is you're studying do you have when you start the timer? When you have an equation or you study something, you always have to have a starting point. When you throw a baseball, how high off the ground is it when you release it? That's the initial value of the altitude of the ball, right? When you save money, let's say that I tell you, I'm going to give you $5,000 per day. $5,000 per day. That's a lot of money, right? $5,000 every day. Next day, $5,000 more. Next day, $5,000 more. Next day, $5,000 more. How much money do you have? Well, you can't tell me because it depends on what you start with, right? If you have zero money in the bank to begin with, then $5,000 per day, you can tell me how much it adds up to. But what if you already started out with $10,000 in the bank? Well, then, of course, you have a slightly different answer than before. What if you're in debt $200,000 when we start? Well, this is going to take a while for my gift to you to dig you out of your debt to be able to go into the positive territory. So the initial value is how much money was in your bank when we started giving you the money, the initial value of the money in your bank. Right? So it doesn't make any sense to say, I'm giving you $5,000 a day. After 15 days, how much money do you have? Because you have to tell me, how much did I start with? That's the initial value. Every problem, I can't even think of really any problem in real life doesn't have some kind of initial value with it. Even if it's particles that collide, like, balls or something, you have to know their initial positions, their initial velocities when you start looking at the situation. You have to know that or you can't solve anything. So let's just take this one little step further. If I tell you I'm going to give you $5,000 a day, then we might write it like this, 5,000 times x, where x is the number of days in the future, right? On day 1, that'll be $5,000. On day 2, that'll be 2 times 5, $10,000. On day 3, that'll be 3 times 5, $15,000, and so on. But it's going to form a line because I don't know the initial value of what I started with. What if I started with $5,000 times the number of days, and I started with $10 in my bank? Well, then I'm going to take that and I'm going to add it to the $10 I started with. That will be the final amount of money I have after that many days. But what if it's 5,000 times the number of days, but I actually started with $1 million in the bank? Well, this is going to give a completely different answer for how much money I have, because I already started with a huge amount of money. Yes, I'm adding to it, but it's kind of dwarfed by how much it's going to very slightly change this, right? Because I started with so much. But what if I started with 5,000? And you can do it as plus a negative debt, but let's just call it negative, $5,000. That's a debt. That's plus a negative amount of money. So in other words, on my first day, when I get my first $5,000, 5,000 minus 5,000 is 0. I have erased my debt, and then I can begin to start saving that money again. So you see, these three situations only differed by the numbers over here at the end, but they give wildly different numbers. You cannot solve problems without an initial value, without knowing what the system is doing when you start. When you start a car, what position are the pistons in? When you start a rocket engine, how cool is the combustion chamber? How is the density of the atmosphere when you fly an airplane? You don't know how the airplane will fly unless you know the air temperature outside. There are lots of initial conditions in real life. But I want you to notice what this is. Y equals mx plus b. Y equals mx plus b. Y equals mx plus b. I'll just write it down. Mx plus b. This thing over here, separate from the mx, this thing is called the initial condition, or the initial value. It could be the initial value, it could be the initial temperature in a room. It could be the initial amount of money you have in the bank account. It could be the initial altitude you start when you climb a mountain. It could be the initial depth of a submarine under the water. You have to know the initial value of what you're studying to do anything. And this initial value is tied to the Y-intercept that we studied before. We never called it an initial value because we have to crawl before we can walk, right? But it kind of makes sense that the initial value is the y-intercept, because if I draw some random line, just any random line, here's, y is equal to mx plus b, or f of x is equal to mx plus b, however you want to call it. Let's go and do this thing right here. That's my line. What does it mean to have an initial value? The initial value of something is what you have when you start at time 0. And if you consider x, whatever it represents, to be the thing that's increasing, the time or distance or whatever it is, then when you set this equal to 0, 0 times any slope is 0, then when time is 0, or when whatever you're studying, distance is 0, when whatever system it is, when x goes to 0, this is the thing that is left over. It is the initial value when this is 0. This thing down here is the initial value. And it's the initial value because when x is 0, that is where the line crosses the y-axis. That is why the y-intercept, the b value, is the initial value for the problem. It's because all lines have the form mx plus b. And x is what we call the independent variable. It's what changes. So whatever it is, usually it's time in real life, or it could be distance from 0 or something. When that starts out at 0, that's when the experiment starts. When you put 0 in for this, it kills all this stuff, and the y-intercept is what you have at the beginning when this thing is set to 0. That is the same as the crossing point for the y-intercept. So keep that in mind as we solve our very first problem. Here it says, the table below represents a linear function that shows the relationship between the length of time Rachel spends reading, x, and the number of chapters she has read, f of x. So she's reading a book. How many hours in the future? We have a table of values. Okay, 2 hours into her reading session, she's read 6 chapters total. 5 hours into her reading session, she's read 12 chapters total. 7 hours, she has read 16 chapters total. But what's missing from this table is, what did Rachel read before we started this experiment? Maybe she read some chapters the day before, and then we're starting this experiment now at time 0. She may have already had 2 or 3 or 4 chapters in the bag, initial value, just like initial amount of money in the bank. Maybe she already read a couple of chapters. Let's find out. And I'm actually noticing as we start here, I apologize for this, I really do, but I have some typos here. This is actually 4, this is actually 6, this is actually 7, and then over here, this is 4 chapters, and this is 6 chapters, and this is 8 chapters, and this is 9 chapters. And I could probably edit this out of the video and that would be okay, but honestly, I think it's important every now and then for you to know that I make mistakes too. I started this problem, I had some numbers, and then I changed the numbers to make them a little bit easier. But then I didn't update my table, and I'm sorry about that. I could change it, and erase everything, but honestly, I make mistakes too. It's okay for you to know that. So, at 2 hours, I read 4 chapters. That's the point 2, 4. At 4 hours, I read 6 chapters. At 6 hours, I read 8 chapters. And at 7 hours, I read 9 chapters. These are the points I want to graph. I'm sorry about that. Let's go ahead and do that. So 2, 4, 4, 6. So 2, 4 is right here, and 4, 6 is right there. So far, so good. It forms a line. Then we have 6, 8, and 7, 9. So we have 6, 8 here, and then 7, 9 right here. So it does form a nice line. Now look at what happens. When I draw a line through these points and continue to extend that line, again, predicting data that's outside the table that I have printed on the page, then you can see that the y-intercept is going to be at a y value of 2. And that means the initial value for this problem is 0. At 0 time, I actually have 2 books in the bag. In other words, maybe 3 weeks ago, I read 2 chapters of the book, or she did, and then I start this experiment and tabulate this information. It's just like the bank account. How much money do you have in the bank? It depends on the rate of the money I'm giving you, but also in how much money I started with. In this case, I started with 2 chapters. The initial value is 0, 2. So we graphed it and we know the answer ahead of time. But in all the future problems, what we actually want to do here is we want to calculate the initial value. We want to calculate the y-intercept b value, mx plus b. We want to find the b value because the b value is going to correspond to the initial value for this problem. The title of the lesson is the y-intercept as the initial value of a function. We want to find the y-intercept. That tells us what the initial value is. How do we do that? All we have are these points, but you know a lot actually, because you know how to find the slope, right? We can calculate the slope, and you also know that f of x is mx plus b. You know the form of every single line, and it says here it's a linear function. So when it tells you it's a linear function, you already know it has to be some number m times x plus some number b, okay? So first, let's calculate what we know we can find, the slope. You can choose any 2 points you want. I'm going to choose these two. 6 minus 4, the f of x values, 6 minus 4, and 4 minus 2. Right? And what is this in terms of units? We're subtracting chapters on the top, chapters, and on the bottom, it's per hour. So what we get is 6 minus 4 is 2 over 4 minus 2 is 2, is 2 divided by 2 is 1 chapter per hour. So in the previous lesson, we calculated and talked about the rate of change of a linear function. So we're kind of tying this in here as well. We figured out what the slope is, and we get a slope of 1, and that's true, but the units of this slope are chapters per hour. And that tells you, as I'm reading this book, it lets you predict how many chapters I'm going to read in 1 hour. 1 chapter for every 1 hour. And that's a linear thing. So every hour that goes, I read 1 extra chapter. So you might say, great, you calculated the slope. How does this help me find the y-intercept b? Well, you know that f of x is equal to m times x plus b. And you know you want to find the y-intercept, right? So we can substitute in here. We can say that f of x is equal to m, which is the slope, which is 1. So 1, you can do like this, times x plus b. Let me ask you a question. This f of x, we've been talking about it for a while now, but we know that f of x is the same thing that we used to call just the value y. 1 times x is x plus b. So now you know the equation of this line. Y is equal to x plus b. And what you can then do is you can use any of the points that you have that are already on this line. You already know 4 different points on this line. Let's pick the first one. When x is 2, remember this is x comma y, so this is x comma y. When x is 2, y must be 4. So let's go put that in here. And let's continue down here. When x is 2, y is 4. So if I know that y is equal to x plus b, then I know one of these points. When y is 4, put it into the y position, x must be 2 because this is a point on the line. Like this. And now we have an equation. We now know how to solve equations. We can solve for b. We can subtract 2 from both sides. 4 minus 2 is equal to b. All I did was subtract 2 on the right, making it 0, subtract 2 on the left, and you get b is equal to 2. The y-intercept is equal to 2, right? That means that at 0, 2, that's the initial value, which is exactly what we have already shown on their other plot. When we actually connect the dots outside of our data points, it does indeed cross right here, initial value of 0, 2. That means at 0 hours, when she has really not started this experiment, she already has read 2 chapters of this book previously. That's her initial value. Now, the other thing I want to show you before we solve the next problem is, once you know the equation on the line, y is equal to x plus b, we use this point here. Let's use a different point. Heck, let's use this one down here, 7 and 9. So when y is 9, put this in here, x is 7. You see, we have the same thing. What we'll do is we'll subtract 7 from both sides. And so what you figure out is b, again, is equal to 2. So how do you do this kind of problem? Basically, when you want to figure out the initial value, you know that it has to be y equals mx plus b, or f of x is equal to mx plus b. That is locked in place. You can always find the slope when you have at least 2 points, so find it. And then stick it in there and write down your equation of the line. And then just use any other point that you know on the line to stick in for the y and the x values, because you know it has to be on this line. And no matter what point you put in and solve for b, you will get the same answer. And you interpret that as the y-intercept, where the graph is crossing the y-axis being the starting position of the data that we have for the problem at hand. So that's an initial value. And I cannot stress enough. We're going to do more problems, but I can't stress enough, because when you go into advanced calculus, we have entire problems that are focused on they're called initial value problems. And they're more complex than this, but it's really the same idea. It's what is happening when you start. And so I can't stress enough how important this is. Let me take this down. We're going to do a couple more to wrap it up and finish out this topic. All right, here's problem number 2. The table below is a linear function, that's a line, shows the relationship between the number of weeks Trey works, x, and his bank account balance after depositing his checks, f of x. So after 3 weeks, he has $400 in the bank. After 4 weeks, he has $500 in the bank. After 6 weeks, he has $700 in the bank, and so on. That's what the table is telling us. But it's just like when I opened the lesson. How much did he have when he, before he started working? So you get a job, you start getting paychecks. Okay, that's adding to what you have, but what did you start with? That's the initial value. How do you figure out the initial value? So our strategy is, we know that this is a linear function. So we know that, you can say f of x or y, whatever you want to think about it, is equal to mx plus b. You know this. But we can find the slope from one pair of, or two of these points that we have here. So the slope, you can calculate using whatever point you want. Let's choose this one, 500 minus 400. So the output, or the y value, minus 400, or the f of x value. I subtracted this way, so I'm going to subtract this way 4 minus 3. And so 500 minus 400 is 100 over 1, which when you divide by 1 is 100. And what are the units here? We were subtracting money on the top, so it's dollars per, and we were subtracting weeks on the bottom, week. So basically we figured out that the slope of this thing is his basic paycheck is earning him $100 per week. So you can kind of calculate in the future, after 4 weeks, about a month, he'll earn $400 or more. But we don't really know how much money this person has, because we don't know if he has $10 million in the bank to start with, or if he has like 0 in the bank, or if he's got like a debt of $50,000. We don't have any idea what he started with. We have to find that. But what we can do is we can take this slope and we can stick it right into there, and we can say that our function is the slope being 100 times x plus b. Now, how do we find this y-intercept, right? How do we find it? Well, we can choose any point we want. I can choose this point here. I can choose this point here. I can choose this point here. I can choose this. It really doesn't matter. You're going to get the same answer. Let's choose the first one. At 3 weeks in x, the output f of x, we also used to call that y, was 400. This has to be on the line. So we can put an output of $400. That's how much he has when the input is at 3 weeks. 100 times 3 plus b. So make sure you understand, this is the function. It's a line, okay? mx plus b. At 3 weeks, he has $400. At 3 weeks, he has $400. This pair of numbers goes into here because it has to be on this line. So we have 400 on the left, 300 on the right, and now we can solve because we can subtract 300 from both sides. 400 minus 300 is equal to b, because when I subtract 300 on the right, it disappears. And so on the left-hand side, you get 100. 100 what? What are we talking about? It's $100 initial value, right? $100 initial value. That's the y-intercept. The initial amount of money he had before he got his, before he started his job was $100. So let's take a look at the graph of these points. 3, 400, 4, 500, 6, 700, 8, 900. 3, 400, 4, 500, 6, 700, 8, 900. Just double check ourselves. So 8, 9, 6, 7, 4, 5, 3, 4. 8, 9, 6, 7, 4, 5, 3, 4. So you can see that we have graphed it. This forms a nice, neat graph, and whenever you extend this line down, it crosses exactly here at a y-intercept of $100 existing at time of 0, when he basically didn't start the job yet, or maybe the first nanosecond he went in there before he earned anything. His initial value was $100, so you can put it as a point at 0, 100, meaning at time 0, he had $100. I can't tell you how important this kind of thing is, because in the future, any kind of problem, throwing a baseball, launching a rocket, anything, has some kind of initial condition. What speed did this bullet start at coming out of a gun? How fast were the ice skaters traveling down the rink or whatever before they collided? These things are prevalent everywhere. And so in this case, whereas in the first problem, we kind of gave the punchline away and then we proved it, in this case, we actually did the math first, showed ourselves that the initial value was $100, which would be the y-intercept. And we can then verify that that is the case. So in your mind, the point of this lesson, what I want you to do is start to associate when you see a graph coming down here and crossing the y-axis, I want you to associate that y-intercept with the initial value or the initial condition of whatever problem you're solving. All right, let me take this down. We have one more and we'll wrap up this lesson. Okay, here's our last problem. The table below is a linear function, which is a line, shows the relationship between the number of attendees entering a party, how many people come into a party, and the number of goodie bags left to give out, f of x. So when you see more and more people coming in the door, what's happening is when they come in the door, you give them a goodie bag, or a gift bag, right? And of course, you have a finite supply of these things, you're giving them away, and as more people come in, the less and less bags you have remaining to give out. So the question we want to ask ourselves is, how many goodie bags did you start with before the party started? That's the initial condition. How many bags did I start with when, I guess, before the first person came in? Well, we know it's a linear function. So we know that it's going to look like mx plus b, right? And we know we can always find the slope because we have at least 2 points here. So the slope is going to be, you can use any point you want. I'm going to go 10 minus 6. And since I subtracted this way, I'm going to subtract 4 minus 8. 10 minus 6 is 4, and 4 minus 8 is negative 4. So the slope is actually negative 1 there. And what are the units? It's bags per attendee. So it's bags per attendee, which means that basically you get one, you give away one bag for every person walking in the door. That's what it means. So the slope is negative 1. So if we go over here and we substitute this in over here, then what we learn is that f of x is going to be equal to, when we put a negative 1 in here, we're going to have negative 1 times x is negative x plus b. This is the line. You can replace this mentally with y equals if you want. Mx plus b, that's what it is. Now, to figure out what the y-intercept is, you got to pick some other point on here. It doesn't matter which one. Let's choose this one at the end. And we're going to substitute that in. So we know that when the input is 10 people, we have 4 bags left, f of x. So we'll put 4 bags left when we have 10 people that have come in the door. 4 bags left, f of x, when 10 people have come in the door. All right? So we want to calculate this. So what we're going to do is we're going to add 10 to both sides. On the right-hand side, when I add 10, it's going to drop away, and I'm going to have b. And so b is going to then equal to 14 bags initially. Initial condition. Or you can write this as 0, 14. That means when 0 people walk in the door, you have 14 bags. That's what this means. So 14 bags is what you have to have started with to begin with. So let's graph these numbers and see if this makes any sense at all. 4, 10, 8, 6. So 4, 10 here, and then 8, 6 is right here. And the other 2 points are 9, 5, 10, 4. 9, 5 here, and 10, 4 right here. But notice the y-intercept is not over here. The y-intercept is way back up here. It's where the graph crosses the y-axis, and you can see 5, 10, 11, 12, 13, 14. The initial value is that when 0 people have walked in the door, I have 14 goodie bags. That's my initial condition. And you can see that the slope that we calculated, 1 bag going out the door for every attendee, is correct as well, because that means we go down 1 over 1, down 1 over 1, down 1 over 1 like this to make my line in the first place. So in this case, since the slope was negative, it slanted down, but the y-intercept is still in the same place. It's wherever this thing crosses. Here it crossed up here at 14 bags, and the number of bags were decreasing as I gave them away. When the 10th person walked in the door, I had 4 left. That should be a big clue to tell you that when 10 people came in the door, I had 4 left. That means that I must have started with 14 bags. So it's another way of looking at it, and you can kind of cross-check yourself. But this is making sense that you started with 14 bags, because if 10 people came in and I had 4 left, then I would have had to have had a total of 14 altogether anyway. All right, y-intercept as initial value. When we study y equals mx plus b, first we lie to you and tell you it's y equals, and then we tell you it's a function f of x is equal to mx plus b. So that's kind of one lie that we peel away and call it a function. That's new. And then we start telling you that that y-intercept is not just a weird y-intercept, it's actually the initial value of whatever you're studying. And that it has a physical meaning that you can tie to any problem you solve. I mean, all of these problems were all completely different, but they all had an initial value that made sense. Either it was money, altitude, in this case it was a number of goodie bags, whatever it is. So solve these, make sure you understand. Follow me on to part 2, we'll continue building your skills.